Hello, welcome to today's webinar. I'm Hussein Khalil Pasha. I'm pleased to be joined by Tim Edward from OneBridge. Together with Tim, we are pleased to introduce you to our cognitive integrity management solution, which brings together the best of Worley and OneBridge to help you predict and prevent pipeline failures. Today, we'll look at some of the common challenges facing asset managers and integrity engineers, how digital technology is accelerating integrity data management, and how we are overcoming challenges through our cognitive integrity management solution. So if I ask each of you, what is your common integrity challenges, you will probably come up with few items. And this was the topic of questions we asked from several of our customers. And these are some of the main challenges that they have listed. Number one is limited resources, which make it difficult to monitor pipeline conditions continuously. Number two is inaccuracy of analysis due to incomplete data utilization. Number three, increased risk of failure resulting from a time-consuming analysis process. Number four, inaccessible pipeline data, as integrity assessments are vendor-driven. And number five is uncertainty and cost, as a new pipeline data isn't correlated effectively with past inspection data. And probably we can name a few more, but these are probably some of the main challenges some of our oil and gas companies are and other industries dealing with pipelines are facing today. So together with OneBridge, we teamed up with OneBridge and worked to tackle these challenges, leveraging on Worley's expertise in pipeline engineering and integrity, and OneBridge's experience in data science and machine learning technology. So I'll hand over to Tim to give an overview of cognitive integrity management solution and how this digital approach is bringing enormous value to our customers.
Thanks, Hussein. I'm Tim Edward. OneBridge Solutions built a born-in-the-cloud integrity management software package using the latest machine learning and data science technologies. Worley and OneBridge provide faster, more accurate options for pipeline integrity management, helping to minimize the risk and failure and reduce environmental and safety risks while reducing the total cost of ownership for software. OneBridge's software is born in the cloud, and what we focus on is speeding up work, improving data quality, reducing the total cost of ownership, and reducing the risk of stranded critical business technologies. So OneBridge Solutions started with inline inspection data. And one of the first things we learned is inline inspection data came in many forms. To solve the ingestion problem, we wrote ingestion algorithms, which included ILI and third-party data services, such as close interval survey data and many others. The next step was to build a series of learning areas, and that started around alignment. From alignment, we got into pattern detection, we got into interacting threats, and we're continuing to evolve future algorithms. The next step was to build out a business intelligence platform. We're using Power BI in this to surface all the intelligence that comes out of the cognitive learning process. The next step was to then make those threats or that information available in the form of threat monitoring available to the operator. From there, the process then controls the development of dig programs and also cycles that data back into the process and starts the cycle over again. The latest module that's been added to the system is the CFIR probabilistic risk models, and we'll talk more about that later. Hussein?
Thanks, Tim. So just keep in mind, if you want to learn more, stay online here to participate in our Q&A session, which will come up after this session. So please, keep notes of your question and drop them down in Q&A tab below the screen, and we'll definitely come back to it at the end of this session. Now, following up on this solution and how the mechanics of the solution is developed, we thought the best way to show and demonstrate the capability of the tool and how much value it can add to the operation companies, we go through some of the examples of case studies that we have performed the last 12 to 24 months across the globe through Worley and OneBridge relationship. I just wanted to say that based on our knowledge of the market and existing tools and solution in the industry, SIM is the only solution in the market that is fully commercial and in use today by integrity engineers industry around the world, which can leverage AI, machine learning, and data science at its best capacity. And the following few cases that I will go through explain some of those values across the areas that Tim has just outlined. Now, if I go back, there are these examples that we'll go through are about 5 different sets of pipelines or single pipelines in cases. One of them is about the work that we have done for a pipeline operator with more than 60 onshore oil and gas pipelines, combination of oil and gas. The other one is for a single pipeline, which was about 200 kilometer onshore. The third one is about a 70 kilometer onshore gas pipeline. Fourth one is 700 kilometer offshore oil and gas pipeline. And the last one is a 50 kilometer onshore with an offshore section of oil pipeline. I'll go through the example case studies for each, and we'll elaborate more about each of those assets as well as we speak. So the first story that we'll go through is about how SIM enabled an operator to save time and knocking weeks off a typical assessment process. Time some people say is equivalent to gold or money. And in this case, you'll see how much time has been saved through using SIM. So this is an operator which had is an SIM operator with more than 60 flow lines. The pipelines, as I said, carry oil and gas. They have been performing ILIs for the last 20 years. And the dig up program was behind the schedule. And as you can see, the repair program was ineffective. They had high dig to repair ratio whenever they had to dig up, and they had increased failure or leak, which results in production interruption. You can see here on the screen their failure rates, which was significantly increasing in the past 5 years. The main integrity department's challenge was time-consuming process to identify dig locations. So we implemented SIM across these 60 flow lines, and as you can see, an example of one of the flow lines which had multiple ILIs, 3 ILIs, and through enhancement of SIM's capability, we saved time. Basically, we used machine learning to ingest inspection and align data, which you normally would do manually through multiple spreadsheets. The integrity engineers around the room who has been using ILI tallying inspection sheets and trying to align them. We'll have a lot of stories about months and weeks spending to align single anomalies sometimes, and sometimes it's just practically impossible. But with using the machine learning capabilities, we managed to ingest all ILIs in a very, very rapid, very quick time frame. We complete this every assessment in hours, not months, as it's typical. And we assess 60 flow lines in 100 days, providing a dig to repair program for the next 5 years. And this was about 160,000 anomalies. And if you put that into perspective, I think you would agree that even if you assume you had all the data using traditional methods, it takes you 2 to 4 weeks to run an assessment and come up with a dig up program for a single line. If you multiple that 2 to 4 weeks by 60, we're talking about 120 to 240 weeks compared to 12 weeks or 100 days. So that's a significant improvement in time. And as a result, you change the approach from reactive to a proactive approach, because immediately you can start to look at your dig up program. And that's what integrity engineers should focus on. Focus on what should they do next rather than sitting on data for a long time, because data doesn't enable them to make a decision at its own. So this second story, which I'm going through today, is about how the tool enabled the operator to save costs. Obviously, in previous example, when we save time, cost comes as a secondary outcome as well. But in this example, I'm going to talk about a pipeline which we help the operator to save on the cost and optimize the maintenance investment. Given the current climate, I think there are very minor number of operators who cost is not the main driver. It's I'm confident to say most of our customers are heavily focused on optimizing the cost and finding the best smart solutions that help them to do that. So in this case, this was a pipeline operator with an aged pipeline. The pipeline ran through environmentally sensitive area, and the existing assessment showed to increase pipeline pressure, a significant investment was required. And the current assessment conducted a progressive investment to pipeline repair in the next 5 years. So the main challenge for integrity engineers was calculating the accurate corrosion growth rate and forecast inspection program. And it goes without saying, in a conventional or traditional methods of assessing anomalies and fitness for service assessment, we usually use a small portion of data to make the decision for the rest of the inspection data. And this is just because managing 100% of the data is not humanly possible. Where in this case with SIM, the machine helps us to do that instead of us sitting on our desk playing with spreadsheets to do that. So in this case, as you can see, we managed to save costs using machine learning to utilize 100% of the data. And one of the main enablers of that was using pit-to-pit corrosion growth rate calculation. And this is from many researchers so far, the most accurate and cost-effective solution for identifying, dig up, and calculating corrosion rate. And it's possible because we can align multiple ILIs throughout the history of the pipeline. And by aligning ILIs, we can align anomalies and calculate the accurate corrosion rate. And imagine if we were not able to align the ILIs, we had two other options, either through assuming a flat rate corrosion growth rates, which is the most conservative one, basically looking at the data sets, looking at the maximum anomaly size, minimum anomaly size, do a probabilistic assessment, and come up with some sort of probabilistic curve to understand to come up with the corrosion growth rates, which in a lot of times is super conservative. And interesting enough, some studies shows that sometimes is non-conservative. So to put it very brief, it's very, very inaccurate. The second option is using half-life calculation method, which is basically taking the time between two inspections and multiplying by 2 to calculate the corrosion growth rates, which is, as you can see, inherently has a safety factor of at least 2, if not more. But with the pit-to-pit corrosion growth rates, you can accurately calculate the rate of corrosion on an anomaly. And the difference in cost is significant. As you can see in the screen, the 3 different colors show 3 different approaches. This is the flat rate calculation, which is very, very common in the industry. This is using half-life calculation, and this is using pit-to-pit corrosion growth rates. And as you can see, especially over time, there's a significant cost-saving difference between half-life and pit-to-pit corrosion growth rates. Just worth noting that when we use SIM, the tool is able to use either of these methods, but obviously most of our clients choose to use pit-to-pit corrosion growth rates because that's very accurate. And here's another of the same project example of calculations of number of dig up that was required, and what was offered by SIM versus what was offered by existing calculation. You can see a significant difference between the two. And interesting enough, using SIM, this operator wanted to increase the pipeline pressure. And as you can see, if you use SIM, the difference is 0. With using traditional methods, there's a significant difference between almost 2 times. And that's inherent in the methodology because as I mentioned, traditional method, you assume a corrosion growth rates. And obviously the relationship between that and pressure is is dominant in deciding number of anomalies. So in short, using SIM, we estimated the cost of maintenance in 5 years is reduced 4 to 9 times, and the increasing of pressure offers no additional threat. And also, we managed to reduce the ILI frequencies, which all three of them are significant cost saving, very significant cost saving for the client. The next story is about reducing risk by early identification of integrity threats, and this is for an upstream wet gas pipeline. So this is for a pipeline which was, as I mentioned, an upstream wet gas line. We were able to support an early detection of a risk of integrity threat to this customer. So this customer had an ILI in 2008 and a second ILI in 2018 within 10 years interval. So the data visualization and Power BIs enable the integrity engineer to actually drill down to understand what are the integrity threats. The time is spent on assessing the integrity rather than trying to come up with dig up without looking at the patterns. And as you can see here, between the two ILIs, there is a significant increase. This is the clock position of anomalies, by the way, and this is how anomalies are distributed by size. And between two ILI, there's a significant increase in number of anomalies at top of the line. And next, when you look at the anomaly distribution by odometer, you see a significant population of anomalies in the first segment of the pipe. This clearly indicated that there's a corrosion mechanism at early segment of the pipe at top of the line. And when we shared that with the clients, and when we looked at the pipeline historical data, it was very quick enough for them to understand there is an internal corrosion mechanism going on at the first segment of the pipe. And it was very timely because these anomalies were not significant in size yet. And this has helped them a lot to identify this internal corrosion threat and control it. And if they have left this for another few years, they had to replace this section, as you can imagine, because of the number of anomalies and this increasing rate of corrosion. So this is a significant time saving, cost saving, but also making the smart decisions, as I mentioned before, enabled by the power of the tool. And we have a lot of similar stories that that early intervention was possible through using this software. And this is 2 weeks after the ILI. You know, in this case, this was 2018 ILI. But in a normal day, if you use SIM, this will be within a few days after your second ILI. You can do an early intervention and stop a corrosion mechanism. And just imagine if that ILI assessment is left for a long time, and you come back to ILI, then this is not where it was during inspection. This is probably has significantly increased. So time plays a key role in any intervention pipeline integrity management. So the next example is about how we managed to improve accuracy by assessing effectiveness of corrosion management strategy for an oil pipeline. Again, this is a similar story using the pattern detection capability of the tool. This is a pipeline, an H pipeline, and it was an old pipeline, and the asset owner has run 3 ILIs, 2011, 16, and 20, and internal corrosion, bottom of the line, MIC was the main integrity threat. But as you can see between these 2 ILIs, this shows that the internal corrosion or the bottom of the line corrosion is not only at the bottom of the line anymore, but it's distributed across the circumference. And if you look at the number of anomalies, it seems that there's a significant increase in number of anomalies. And what that tells us is basically between these years, the corrosion management strategy has been ineffective. In this case, the batching was ineffective. And instead of preventing the internal corrosion mechanism, or in this case, MIC at the bottom of the line, it was very ineffective that it actually has been spread all over the pipe to the top of the line at all clock positions. And this raised the issue of effective corrosion management strategy. And in this case, the client or the operator had to go back, revise the corrosion management strategy, the pigging frequency, the batching material that was used, and a few other actions to prevent this mechanism to further grow. And in this case, and with these kind of anomalies, there's no way to repair the pipe because there are significant number of anomalies, and you will be facing a lot of pinhole leaks very, very often. So early intervention is the key. Otherwise, the only option becomes replacing, which is a very costly program. And the last story is about how the tool helps us to increase decision certainty by identification of unsuccessful inspection. It's a very common practice in our industry, again, because of time and all other restraints that we have on our day-to-day. When we get an inspection report, we look at the top 25, top 50 critical anomalies, and we try to get ahead of the game by starting our dig up campaign, where in some cases, this is not necessarily, should not necessarily be the case. And this is one of those. So this pipeline operator had, this is an oil pipeline, the section onshore and section offshore. They had ILIs every 2 years. This is 2016. The second ILI was 2018, and they did a third ILI in 2020. And we were involved at the early stage once they received the ILI report and asked us to do to identify the dig up locations. Again, as you can see here, the pattern of internal corrosion is bottom of the line, and the latest one showed strong presence at top of the line. Given the time difference between two ILIs, it was for us, it was a bit of suspicion in it, whether 2 years is, yes, some corrosion mechanism can be active in 2 years, but is that probably the right assumption to make? So we went back to the operator and we reviewed their inspection and corrosion management program for the last 4 years. There was not a significant difference that was monitored or they found in the last 4 years. So we had to go back to the ILI vendor and present this to them. And we had few discussions, and as a result, we found that the tool has changed between these two ILIs, and during the data interpretation, there was some complications about coming up with pipe tally, and for some reason in those steps, the anomaly orientation was flipped instead of top to the bottom, instead of bottom to the top. So they had to revise the pipe tally, and as it turned out, the actual analysis post that process showed all the anomalies are bottom of the line. Now, imagine if this operator had to take this at the value, at face value, and had to go out and do the dig ups. The dig to repair ratio, I bet, would have been very, very high. So, and this happened immediately after we ingested the latest ILI into the tool. It takes you an hour to be in this position before making any further decision. So basically, the tool enabled us and our operator to identify an unsuccessful inspection and revise it. So in summary, I think we, through these examples, demonstrated that using the machine learning and SIM, we managed to save time, save costs in almost all these cases, reduce the risk by early intervention and getting ahead of time for a large portion of ILIs or flow lines in some cases, improve the accuracy of our assessment and increase the certainty. That's all I had to share for today. So our contact details is here. Please feel free to contact me or Tim if you had any questions. Thank you very much for your time. And if you want to learn more stay online here to participate in our Q&A session, which is coming up next. A few of our other colleagues will be joining the Q&A, and we'll be more than happy to take any questions. Thank you and see you.